Let's look at this absolute value equation. Now, the technique we've been using requires us to first, on one side of the equation, isolate the absolute value, and then have our constant on the other side. Well, we don't have that right here, do we? We have the absolute value quantity plus a constant equals a constant. So the first thing I need to do is I need to get rid of the constant here so that I can isolate the absolute value expression. So I'll subtract 6 from both sides in order to do that. Subtracting 6 from 9 gives me 3. Now I can draw that conclusion. If the absolute value of this quantity is equal to 3, then this quantity, 1 minus 2x, must either be 3 or that quantity 1 minus 2x must equal negative 3. Because the only two quantities that have an absolute value of 3 are 3 or negative 3. So if the absolute value of that quantity is supposed to be 3, that quantity has to be 3 or that quantity has to be negative 3. And that creates two nice linear equations that I can solve. I'll subtract 1 from both sides here. That will give me negative 2x equals 2. Subtracting 1 from 3 gives me 2. And now I'll divide both sides by negative 2, which gives me a solution that x is negative 1. Here I'll subtract 1 from both sides. Negative 3 minus 1 is negative 4. And now dividing both sides by negative 2, I get x is 2. So if x is given a value of negative 1, the equation is true. If x is given a value of 2, the equation is true. And I use that same technique, but in this case, first of all, I had to isolate the absolute value expression before I could create my two equations to solve.